Welcome to our session, children. In today's session, we are going to discuss about chapter number 4, Quadratic Equation. In today's chapter, we are going to discuss few very important things about quadratic equations, their solutions, their different methods. So, children, let's begin with the chapter number 4, Quadratic Equation. So, children, let us discuss the content of this chapter, that what are the things which we are going to discuss here. In this chapter, we are going to discuss about quadratic equation, zeros of quadratic equation, solution by factorization method, solution by using quadratic formula, and the last thing is about the nature of roots. So, let us start the chapter. Children, we already learnt about quadratic equation in our chapter number 2, polynomials. Quadratic equation is an equation in variable x with the degree of the equation is 2. When the highest power of equation is 2, it is said to be a quadratic equation. For example, you can see I have written an example here, 3x square minus 4x plus 1 is equals to 0. You all can see here the degree of the variable is x, that the degree of the variable x is 2, that is why this is said to be a quadratic equation. The standard form of quadratic equation is written as, for say p of x is any quadratic equation, then p of x is equals to ax square plus bx plus c is equals to 0 is known as standard form of quadratic equation. Remember, here a cannot be equals to 0, because if this a becomes 0, then this term of quadratic equation get vanished and your equation reduced to bx plus c equals to 0, then in that case this equation reduced to a linear equation. So, in the standard form of quadratic equation, ax square plus bx plus c, which is equals to 0, the coefficient of x square will not be is equals to 0. Here are few examples of quadratic equations. We have two cases here. This both are the examples of quadratic equation. Children, but in the case 1, the examples which we have written here, the example here a, b and the c, they are not equals to 0, and these quadratic equations are already in their standard form. But in case number 2, if you see here, first equation is only x square minus 3 equals to 0. I am writing it here, it is x square minus 3 is equals to 0. If you compare this equation to the standard form of quadratic equation, you will see here coefficient of x square, that is a's value is 1, but there is no term of x, means b is equals to 0. But since here the degree of the variable is 2, that is why this is considered as an example of quadratic equation. Similarly, in the other examples also, here the constant term is missing. Here in this example, here the constant term is written on the right hand side, and in the last example the middlemost term is missing, but still they all are the examples of quadratic equation. To judge whether the given equation is quadratic equation or not, you only have to keep one thing in your mind, that the degree of the variable or the highest power of the involved variable will be is equals to 2. Now, few examples are there and you have to check whether these examples are actually forming quadratic equation or not. So, children, this is example number 1. X minus 2 whole square plus 1 is equals to 2x minus 3. When you go to the next step, children, here you are going to open this by using identity number 2, that is a minus b whole square. A minus b whole square is equals to a square minus 2ab plus b square. So, open this bracket by using identity. Apply identity here, this is a, this is b. So, this gives you a square minus 2 into a into b, that gives you 4x, and plus square of b, that is 4. And here you have 2x minus 3 as well. Now when you do transposition of the terms, children, bring all the variables to one side and the numbers to one side and just keep 0 to the right hand side. Your equation will reduce to x square minus 6x plus 7 is equals to 0. Children, you can see when you compare this equation is written in, or this is the standard form of a quadratic equation. Clearly, this is in the form of ax square plus bx plus c is equals to 0. Therefore, the given example is forming a quadratic equation. So, let us understand one more example. Here, the example is x in a bracket x plus 1 plus 8 and this is equals to x plus 2, x minus 2. So, again start performing or start finding product on both the side. When you multiply the first bracket, you will get x into x gives you x square, x into 1 gives you x and plus 8. Children, you can see here the right hand side is in the form of a plus b and a minus b, or it is a product of a plus b, a minus b, that is equals to a square minus b square. You can directly multiply them or you can apply identity over here. So, when you write down or when you find the product, cancel out the common terms. You can see this x square and x square get cancelled because they have a different sign. Similarly, this negative 2x and positive 2x also get cancelled, and at the last you will left with x plus 8 is equals to minus 4. Now, on doing transposition of this minus 4, it will become positive 4 and your equation is reduced to x plus 12 is equals to 0. Now, children, what is the degree of this variable here? Clearly, you can see the degree of the variable here in this equation is 1. So, that is why this equation is not in the form of ax square plus bx plus c is equals to 0. This implies what? This implies the given equation is not an example of quadratic equation. So, in this way, children, by finding the product of right side and left side, you can check whether the given equation is a quadratic equation or not. Next is, we are going to discuss about the zeros of polynomial. Children, zeros means the value of x which when we substitute in the given equation, your equation will reduce to 0. For example, the given equation here is x square minus 2x plus 1. Let me substitute x is equals to 1 here. Children, this is just a trial and error method. You can put any value of x and then you can check whether that value of x is a 0 of a polynomial or not. So, here I am substituting x is equals to 1. On substituting x is equals to 1, you will see we have 1 square minus 2 into 1 plus 1. This gives you 1 minus 2 plus 1 and you left with only 0. Clearly, on substituting x is equals to 1 in the given equation, your equation or your expression reduced to 0. That is why x is equals to 1 is the 0 of the given polynomial. A real number, let us understand about the solution of quadratic equation. Solutions, zeros and roots, these are the common terms or these are the same terms used for the zeros of a quadratic equation. So, a real number alpha is said to be a root or solution of quadratic equation if on substituting alpha in the equation reduced to 0. Right. In this case, we can say x is equals to alpha is the solution of given equation, because when we substitute alpha here in place of x, we can see your equation reduced to 0. Children, alpha can be any real number. It can be negative, it can be positive, it can be 0. The important thing which you have to keep in your mind is the zeros or the roots of quadratic equation are the same thing. They are not different. Now, let us understand about the solution of quadratic equation. Children, as we already discussed, solution of a quadratic equation is the value of a variable which when we substitute in our equation, your equation reduced to 0. There are different methods to find out solution of quadratic equation. But in our session, we are going to discuss only about method of factorization and the another thing to find the solution by using quadratic formula. So, let us discuss method of factorization. So, we are very much aware of the factorization, that how to factorize a quadratic equation. In order to factorize a quadratic equation ax square plus bx plus c, we need to find out two numbers p and q such that the sum of p and q is equals to the coefficient of x, and the product of that two numbers, that is p into q, will be is equals to the product of the constant term and the coefficient of x square. To understand this in a better way, let us consider one example. So, here let us find out the factors of the given equation 2x square minus 5x plus 3. As I discussed, to find out this, first we will find out the values of a, b and c. So, on comparing this equation to your standard equation, here a is equals to 2, b is equals to minus 5 and c is equals to 3. Now, you can see here the middle term is minus 5. We need to split this minus 5 in such a way that we want two numbers, so that when we add that two numbers, we should get minus 5, and when we multiply that two numbers, we should get product of 2 and 3, that is 6. So, product of 2 and 3 is 6. Now, think of two numbers in such a way that on multiplying we should get 6 and on adding we should get 5. So, clearly the two numbers are 3 and 2, because 2 plus 3 gives you 5 and 2 into 3 gives you 6. So, if the numbers are 2 and 3 children, so we will split this middle term minus 5x as minus 3x and minus 2x. Here you can see we have splitted this equation as the first term will remain as it is 2x square, middle term you have split it as minus 3x minus 2x plus 3 is equals to 0. Now, you can see in this equation you have 4 terms. Let us form the group of 2 terms. So, this is the first group and this is the second group. Now, from the first group, take out something which is common. You can see here in the first group only x is the common term. So, we can take out x out of the bracket. It becomes x in a bracket 2x minus 3. And from the last group, there is nothing which is common. Children, this is important. You have to be careful. When nothing is common means we can take out 1 out of the brackets. So, here I am taking out negative 1 and we left with 2x minus 3 equals to 0. Again important point, here both the brackets should always be equal. Now, we will take out this common bracket outside, that is 2x minus 3, and the things which are left out will write down in the another bracket. So, if I have taken out this bracket outside, from the first term x is left and from the second term minus 1 is left. So, in this way we got two factors of our equation. Now, what we will do in the next step, we will equate both the factors individually to 0. Your first factor is 2x minus 3. Equate this to 0, you will get from here the value of x is equals to 3 upon 2. And on equating your second factor to 0, you get x is equals to 1. So, children, 3 by 2 and 1 are the two solutions of the given quadratic equation. Here are the few more examples of using the splitting the middle term method to find out solution of given equation. We are going to use the same concept which we applied in our last example. Example number 1, 6x square minus x minus 2 is equals to 0. So, here the coefficient of x square is 6 and the constant term is minus 2. Product of 6 and 2 gives you 12. So, now you have to think of two numbers so that when you add them you will get your middle term, and when you multiply you should get 12. Children, what is the coefficient of middle term here? You can see there is no number in front of x, means the coefficient of x here is 1. So, find out two numbers so that the product should be 12 and the sum should be 1. Okay. So, think of these two numbers. So, I am thinking my numbers are 6 and 2 gives you minus 12 and p plus q should be minus 1. So, my two numbers will be 4 and 3, because 4 into 3 gives you 12 and 4 minus 3 gives you 1. Remember, it is not necessary that every time you have to add the numbers. You can add, you can subtract the numbers to get the same number, which is the middle term. Okay. So, now again split your middle term minus x as minus 4x plus 3. Again form group of 2 and 2. Now, from the first group clearly you can see 2x is common. So, we have taken out 2x outside, and from the last group you can see nothing is common, means we can take out 1 outside. Again you can see this bracket is similar. So, we will take out this bracket outside and the things which are left we will write down here, that is 2x plus 1. Now, equate both the factors individually to 0 one by one. So, when you are equating 3x minus 4 to 0, the value of x is going to be 4 upon 3, and when you are equating 2x plus 1 to 0, value of x will be minus 1 upon 2. So, we got two values of x here, 4 by 3 and minus 1 by 2. These two are the solution of given equation. Same concept we will apply in the second example as well. Here the middle term is minus 2 root 6. Children, you can see here root is involved, but we do not have to bother about the roots. We will factorize them in the same way, and the product of the first and the last term is 6. Now, we have to think of two numbers again, so that when we multiply that two numbers we are going to get 6, and on adding that two number we should get minus 2 root 6. Children, so it is clear that, as we already know, we have learned this in class 9th, that if we multiply root 6 and root 6, two same root numbers, you are going to get 6 only, and root 6 plus root 6 gives you 2 root 6. So, clearly in this way we are going to split our middle term. I am going to split our middle term as minus root 6 minus root 6, and children, now form a group of 2, 2. Now, check what is common in the first group. It is 3 here. 3 means it is root 3 into root 3, and 6 is here, root 6. Root 6 is root 2 into root 3. So, what we can take out here? We can take out root 3 out of the bracket. From the first group, root 3x is a common number, and from the next group you can see root 2 is the common number, as root 6 we can split as root 2 into root 3, and 2 is root 2 into root 2. So, root 2 is common. Again form a group. Children, again equate that two factors to 0, but here you can see both of the factors are similar. Here your ultimate factors are root 3x minus 2, root 3x minus 2. So, when you equate both the factors individually to 0, then you will see the value of x will be root 2 upon root 3 and root 2 upon root 3. So, children, in this example you can see, or you have learnt, that both the values of the zeros are same. Thank you for watching this session.